And get started. So my name is Daniel Campbell. I'm the VP of the Model-Based Definition Business for Capvidia. And so the idea today is to talk, really to focus a lot on real-world MBD workflows that a lot of our users are implementing, with the objective of trying to find a realistic path to implementing real software workflows that actually add value to your organization in some way. But at the same way, finding things that are very practical that could be done without trying to boil the ocean. Before, I'll give a quick background on the QIF standard for those of you who aren't familiar with it. And so we'll kind of start with that, giving a little bit of background about QIF, and then get into just some real-life examples of what you could do with MBD. So, just to start off, a little bit about Capvidia. So, we're a leader in the model-based definition software business with a special focus on machine-to-machine consumption. Here's kind of a handful of some of our customers. I think the main takeaway from this is just the fact that it does cross all types of industries, and also that usually the companies that are implementing MBD right now at this point, they're usually the larger OEMs. So it's the larger OEMs that are really leading the charge in terms of implementing MBD, starting to pass it down through their supply chain, and so forth. We have a couple main product lines that are in our MBD space. So first is our MBD Video software, which is mostly what I'm going to be talking about today. That sort of suite of software tools. And then we have our Capvidia software, which is comparative validation software, where you load two CAD models to tell the differences between the geometry and the PMI. Useful for derivative model validation or revision, sort of revision control workflows. But I'm not going to be focusing on the Capvidia technology today. I'm really going to be talking about the MBD Video software. So like I said, the first thing that I'm going to start with today is giving a little bit of background about QIF. So maybe there are a lot of people out here that have heard about QIF, but you don't really have a very good idea of really what it is. So let me explain a little bit about what the basics are. I'll go over it quickly. If you have other questions about it, we can go over it later. You can come by our booth and we could talk about it. So QIF, what is it? First of all, it's an ISO standard. ISO 23952. It was published by ISO in 2020, but it's actually been an ANSI standard since, I believe, 2013. So it is an international standard now. And what is it? It's a data format for manufacturing quality information. So what this means is that it's starting with the product definition at the core, which is the MBD model. So it's your CAD model, it's your PMI, all fully semantic. And then you could layer data on top of it having to do with quality control plans, quality results information, and so forth. And this third bullet point here, it contains semantic data model for machine-to-machine communication. So it's one of the important elements of how QIF was designed, is that it's not only for the human consumption workflow, where you have a human looking with your eyes at a model and examining it. That is clearly one of the use cases for QIF, but there was a lot of focus put on the ability for software to be able to read the QIF data to enable this sort of machine-to-machine communication. In other words, for example, cryoparametric data being fed into a CMM software tool. So I'll go through this really quickly, just to give a little bit of background about the different application areas of QIF. So at the top there in red, we have QIF MBD. So this is really the core of what QIF MBD is about. This is your MBD model. It's your CAD model. It's your PMI, all semantically defined, machine-readable PMI. And then from there, you can start to layer on information, especially related to the quality plan. So number two, QIF plans would be high-level planning information. Sometimes you might hear about ballooning or bubbling or creating the bill of characteristics. This is all just identifying what on the part needs to be controlled. Next, QIF resources. Number 3, this is where it's a data model that allows you to specify the types of measurement resources, measurement devices you have available. So you can characterize those things so that you can assign them to characteristics to be measured. QIF rules is a data model for specifying best practices or, let's say, measurement templates, measurement rules that your company would like to implement. And then the idea is that these rules can be applied to any given part to come up with a specific measurement plan. Number 5 is mentioned here. It's not QIF, but the reason it's mentioned here is DMIS. For those of you who aren't familiar with DMIS, it's quite an old standard, but it's a standard for driving CMMs. And the reason it's mentioned here is because it's governed by the same body that governs QIF, and it's harmonized. It is harmonized with QIF, so it interoperates with QIF in a very clean way. Number 6 is a really big one. So that's QIF results. QIF results is basically it gives you the ability to capture measurement results information for all the characteristics on your model for all the different serial numbers, all the different components that you've measured. So this is actual as-built information related to your model. I was at a presentation last week by Ian Bolton of PTC, and he was talking about digital twin and what he views as his definition of digital twin. And he was saying that it really consists of 3 elements. First, you have your product definition, and so typically that's going to be your CAD model. So it's your creo-parametric model with all the PMI. The next thing is you want to gather some information about particular instances of your product and gather real-world information about that. And in terms of this digital twin context, often you think about a fully completed, maybe a jet engine capturing vibration or heat coming from a jet engine or something like that. But at the manufacturing level, the same concept exists sort of at the component level. And what we're talking about in terms of the actual data at that stage would be your measurement data, the data that you've gathered. And so that would be the second component necessary for this digital twin concept. And then the third thing is a data model to tie together your as-built product and then your product definition. And so those, with those 3 sort of legs to hold up this idea of what the digital twin is, this really is the perfect instantiation of how you can go about realizing that. So the QIF results is a very, very important element of QIF for our users. And then the final one, number 7, is QIF statistics. And so this is just the ability to specify statistical methods that you're going to apply to your different characteristics, and then optionally some of the results from some of these statistical analysis. So that's QIF. That's kind of a real high-level overview of QIF. That's all the background I'm going to give right now. But like I said, if you have more questions, come by and visit us, and I'd be happy to go into more depth. So from here, here's a little bit of getting into why QIF was created in the first place and why MBD really matters. So let's talk about a basic case in terms of quality. This is really, this really has to do with pretty much anything you do in terms of quality, but let's look at a very basic case of, I need to create a first article inspection report for my part. So the way it's done now is you have a very complicated part you'll design in creo-parametric. You'll create a drawing, you will add annotations to the drawing, and then you print the drawing to PDF, and you give that PDF to a manufacturing engineer or a quality engineer. They take the PDF and they read it and they start digitizing this into a software tool, like a CMM software, or into a first article inspection. So the problem here is obvious, how silly that is to be doing that. And so what's the objective of what we're trying to do in terms of MBD is eliminate that step where we're taking data out into a PDF to have to be consumed by a human in order to be redigitized. So we want that data specified in a semantic way in the model so that this is all machine-to-machine consumption in terms of creo-parametric going into your FAI. So let's look at this FAI a little bit. So current stage, someone will go through this blueprint, add little balloon numbers to all the characteristics. Sometimes this is done by hand. Sometimes you can use optical character recognition software to do this. And you end up coming up with your bill of characteristics, which is your list of everything that needs to be measured, your list of everything that's controlled. And you generate this Excel spreadsheet. And this Excel spreadsheet, in some industries, there are standard spreadsheets like AS9102. But you have this first article spreadsheet, and this is an important document for your first article process. So it's a pretty lengthy process. So this is one of the first areas where most of our customers benefit in terms of jumping into MBD. It's a very easy way to get into MBD, and it brings with it a pretty big benefit. And it's just the simple act of creating a first article inspection report from your MBD. So how does it work? So first, we start with our Creo parametric model, fully annotated. We'll export that to the QIF format. We could load that QIF derivative model in MBD Vidia, and we generate the bill of characteristics. This is a single-click button operation because the data is all there in the PMI. So we could generate this table of what all the PMI that's there in the model. There's semantic associativity between each row on the bill of characteristics and the feature that needs to be measured, so on and so forth. Another single-click operation is publish your report. So from there, we dump an Excel file, and that job's done. And now, there's now the added benefit, though, in terms of this digital workflow, that, which is a fourth step, which is the ability to capture that data, where you could take that Excel file and you could import that back into MBD Vidia and bring that Excel data back into QIF and store that data as QIF data. Most inspection data that's out there is stored for official archival purposes. It's not uncommon to see a scan of a handwritten result, where you have a table of information, there were results written by hand, and it's scanned and it's stored somewhere. We've even visited people where they're storing actual paper documents in a filing cabinet. And that's good, obviously, for archival purposes. You know, you need to check a box that this has been verified, and you know, there are audits and so forth. But in terms of doing any data analysis, it's useless. And so that's the big benefit here. Sort of the first tier benefit that people see is the speed of automating this type of process. But the second tier benefit, which is that you start to capture this once you start to get into this process even more, is the ability to harvest this data in the QIF format so that you can start to do smarter analysis of your as-built data. So it's a pretty big deal. So that's kind of the basic starting point, just a very simple process of generating a first article inspection report. We have a video of this, and at the end of these slides, we'll have a QR code where you can download this presentation. And so, we won't show it now, but whenever you'd like, you could download this and view a little video that kind of demonstrates this. As a quick side note, I do want to mention that, as important as MBD is, and as much as we all want to go to MBD, the fact is that 2D drawings will be here to stay for at least for the short term. I think, for those of you that are lucky, you'll probably see it for at least 5 years, but for most people, it's probably going to be here for the next 50 years. It's just a fact of life. And so it would be desirable to have a single software tool, a single data format where you could manage both your 3D and 2D workflows. So that's something that we are now providing, is the ability to handle 2D drawings in our MBD Vidia software using optical character recognition. If you have a PDF, and that's your product definition, to manage the same workflow, it's also a QIF-based workflow from a 2D drawing perspective. So it's just kind of an important side note. All right, so from here, so we just started with the basics of this ballooning process or this bubbling process. This process of generating the first article inspection, just that basic sort of initial step. So what are some of the next steps that you could do? And so what I'm going to do now is I'm going to explain a little bit. I'm going to try to stay high level because my colleagues have made fun of me about how long I could spend on this slide. But it's basically the idea of an APQP workflow, as we call it, Advanced Product Quality Planning, where you get into more. You could think of it as a ballooning workflow, a quality planning workflow, but you're not just generating a simple first article inspection report. You're generating a full control plan, your full quality control plan. And this can be done from the PMI. So let's start off on this workflow. Where do you start? You have your authority CAD model, your authority product definition. This is your creo-parametric model. You have your 3D annotations specified on the model. So the first thing that you'll do is you'll export that data to QIF. We have our plugin to creo-parametric that will do that. We have server-based tools that will interface with Windchill to do that and so forth. We won't get into it, but of course, when you're generating derivative data sets, you want to be validating that data, of course. One good option for that is Capvidia. And then from here, now we start to build our bill of characteristics. So we have our PMI. Like I said, we can automatically assign a ballooning scheme to all of our PMI. So now we've added characteristics, characteristic numbers, characteristic IDs. In QIF, these are called cupids, to each of the characteristics on the model, to everything that needs to be measured. Our next step is we want to assign criticalities. So we can inject information about the design FMEA, some of the design risks that we know about, some of the severities of these risks, and from there we can automatically calculate what are the critical characteristics on this model. Our next step is we're going to look at now how we are planning on manufacturing this particular component. Based on that, we come up with our process FMEA information that has information about the risks associated with the process that we're using to create the part. So that gives us another sense of risks that we need to mitigate against, and from there we can come up with a way to automatically calculate sample sizes. In other words, how many parts per batch for each of the characteristics on the model do I need to inspect, and statistical requirements that need to be upheld, like a CPK threshold that needs to be upheld for each characteristic in order to ensure process stability. And then our final step to create the control plan would be to actually assign measurement resources to each characteristic in the bill of characteristics. You could use QIF for this. So we have QIF resources, QIF rules that I mentioned earlier. That could be employed to come up with a really consistent way to start to apply measurement resources to your bill of characteristics. And so at this stage, you would have what's called a control plan. So there, now we could start going into the first article process, and we start to create our first article. The result of that, we get some QIF results, which is information about that article or those articles that have been manufactured. We can carry out a measurement systems analysis from that data, and then we can start to inject that data back into the bill of characteristics. So now we've injected measurement resources back into that. From there, we could automatically carry out statistical process control, carry out statistical analysis on that data that's been fed back in, and then based on the CPK requirements that were established up above, make an automatic determination about, is this under control or not? Is this statistically acceptable or not? So we have, that's where we have our statistical decision. And then the last step would be a human decision. Maybe there's something that was deemed a failure statistically, but the human engineer overrode that and says, you know what, no, this is going to be a pass. We've done a functional test and it's okay. So determination, do we need a new batch? Do we need to kind of cycle through this again? If so, you keep looping until no, everything looks good. You reach the stage of PPAP approval. Now it's time to enter into full production. You begin production, start generating large amounts of QIF results data from all of your production data. You can start carrying out analytics on that large amount of data that you're generating. And then eventually, it's time, voice of the customer, it's time for a new revision of this particular model. And you go back to the beginning and start to try to process through it again. The good news about handling revisions in the world of MBD is that, again, it's all digital. And so what it means is you know what's changed and what hasn't changed. So the work that you do on the revision is minimal compared to the initial release. So it's another way in which you can cut down time tremendously on your product development cycle. So kind of a longer slide, but it's a pretty complicated workflow, and this is, everyone's doing this in one way or another, but it's, typically like a bucket brigade of 15 different engineers from different disciplines trying to exchange information to come up with this workflow. And this is a great candidate of something to be digitized. So from there, we'll jump into another workflow Here's another example of what some of our customers have a lot of success with. This is usually the first use case that people think of when you think of MBD. Why are you putting MBD on? Well, to automate a CMM. It's definitely one of the cooler ones. It's much cooler than ballooning. It is more difficult to get into than ballooning. And the reason is that the PMI needs to be perfect. It has to be perfectly semantic. If what you're doing is you're generating inspection forms, it doesn't need to be perfectly semantic. There can be some problems with it, and you could still successfully run through your inspection documentation workflow. But with something like this, it has to be perfect. That's why we usually recommend to people that they start with inspection documentation, start to get that down, and then get into this. That said, if you have not been looking into sort of what your options are in terms of using MBD in the metrology space in the last year or so, you probably want to take another look at it. A lot of the metrology companies have been doing a big focus on implementation of MBD, and really specifically implementation of QIF over the last year. If you have questions about your particular software, whether it supports QIF, come and talk to me afterwards, and I have a pretty good vision of, we hold a pretty good relationship with all the different metrology vendors, and we have a pretty good knowledge of what's supporting MBD, what's not, and at what level. But it's definitely a good opportunity for MBD. So, the next area, non-dimensional quality. So it's just an area not to be overlooked. When you look at a drawing or you look at an MBD model, most of the annotations that you see are dimensional characteristics, geometric tolerances, dimensional tolerances. But there are a lot of non-dimensional inspections that are called out as well. And actually there is use case for this type of inspection for non-dimensional characteristics. An example here is that you see on the upper left is a visual inspection. And this is it's a camera-based visual inspection. It's a workflow that we worked on with a company called Kitov. And we demonstrated this at IMTS a few weeks ago, where we take a QIF model that has specific call-outs, calling out certain surfaces. We had a turbine blade, and it called out certain surfaces, asking to do a visual inspection on certain surfaces, looking for scratches and dents and defects like that. That data was saved in the QIF format, passed along to this visual inspection system. It did an analysis to calculate all the camera angles and levels of illumination that would be needed in order to look at all the surfaces sufficiently to try to find scratches. It created the robot path for doing that. You press a button, it runs the inspection, automatically analyzes the images, finds these defects, and then it could actually save those results in the QIF format. And that QIF data could be imported into MBD Video. So you could look at that MBD model, kind of like that middle picture. You could look at that MBD model, see the visual inspection results, and even see where on the model it was, an image of the defect, and so forth, on a per serial number basis. So it's just kind of an interesting application in terms of non-dimensional quality, where there is a whole world that MBD can get into. This is not what I would recommend as a first step, again, because this is probably the lower number of your characteristics will be in this particular domain, but it is a good area for growth. And then finally, even when it comes to non-quality related things, MBD really is largely about quality. Most of the annotations on your model have to do with quality characteristics that must be upheld. But there are other types of annotations that can be placed on your model that are not related to quality. Welds is one of them. You could specify your welds in 3D, in creo-parametric, in a semantic way. That data can be consumed downstream. You don't need a human to be interpreting a PDF to be doing stuff. And so we work with an organization that does a lot of welds, an end user that does a lot of welds, and we've been pretty busy in this area doing some of the things that we've been doing, generating documentation that can be used as sort of work instructions for the users in terms of how you can how to execute some of these welds. building up quality criteria for the welds that must be upheld, and then the ability to sort of capture information about some of the measurements taken on the welds, and then flagging whether it's in tolerance or out of tolerance. We're working with a weld robotics company right now on helping them to be able to support import of the QIF format so that they could build a robotic path for the weld automatically from the QIF. It's definitely an interesting area. So the last thing I'll just mention real quick is that, like I said, a few weeks ago we were at IMTS. We did a pretty neat demonstration of taking this turbine blade model, starting from there, defining the product definition in CAD, and then flowing through this entire quality workflow that involved a few different areas of quality. And we have a video that kind of explains some of this, and there'll be a link to this video in these slides if you ever want to watch it. But basically, so we generate that, we have that native model, we publish the QIF data from there, we balloon that model in MBD Video, come up with the quality control plan, and then it splits into sort of a few different domains of measurement. We have dimensional inspection, and in that case, it took place with Polyworks, which many of you are probably familiar with. They import the QIF file automatically. They know exactly what needs to be measured. We were scanning it with the ferro arm. It would automatically calculate those results. We had some general inspection, which was just sort of different, general notes and things like that, pass-fail type of inspections that could be entered manually into MBD Video, and then the visual inspection system that I talked about earlier. So it sort of split off into all these various different types of inspection that needed to be taken into account, and then finally all of those results gathered back into one place, where all of the different results from the different domains were gathered back onto that QIF MBD model into the same unified QIF format. So it was a pretty cool little workflow, I think, demonstrating sort of the breadth that you can get into in terms of MBD. And so there'll be a link to download this thing if you want to go and check it out yourself later. And I mean, this is the final slide here, really. It's just just a couple anecdotes from some of our users having to do with the benefits that they've seen in terms of, the first one is generation of a first article inspection report. The second one is more of a sort of a lengthy PPAP process. And then the last one is actually using QIF data in metrology software. And just some of the benefits that some of them have seen. I think one of the takeaways here is that there are a lot of benefits to MBD. A lot of them are intangible, though, and they're hard to measure. Like, for example, the benefit of gathering all of your as-built data, being able to do data analytics on it. How can you quantify that? It's very difficult. But this here, capturing time, is one thing that can be captured pretty easily and can be measured pretty easily. And so it's always a recommendation that we give our users when starting with MBD pilots is, start with taking a known process, find out how much time it takes to do that from a 2D drawing. The best way to do this is find out before you run through the pilot, because lots of times, if you tell the results of the 3D approach, they might try to embellish a little bit about how long it took on the 2D side. So you find out about, how long it took to do this in the 2D world, you carry it out in the 3D world, and you have a really easy comparison that you can use to show some value for the MBD process. And so, so that's it. That's all we have for today. That's the presentation code for everybody who wants to take that, CAP 207. And then, that QR code there is, that's to download this presentation. And actually, we'll have it at our booth, too. Like, if you walk by, you can scan it there. So, with that, we have some time. I wanted to leave some time at the end for questions, if anybody has any. Yeah?
The analytics that you were talking about, is that part of the software? Or are you just saying that once we record the data and get it back, we have it available to do analytics?
It's both, yeah. So we do sort of, let's say traditional SPC, traditional statistical process control, CP, CPK, PP, PPK, stuff like that. But I think it's one important aspect of QIF that, that people need to keep in mind is that it's an incredibly accessible data format. And every large company now has a team of software developers that just basic competence with software, even from people who aren't professional software developers, it's pretty easily possible to generate code that can read and write QIF. And the way QIF is designed, you could ignore a lot of the complexity of the product model, like all the CAD geometry and everything like that, and just look at what's called the features and characteristics. And you could pick apart that data and look at real results and create your own analytics. Because I think, like, ultimately, every company, there are standard analytics that every company is going to want to do, but every company is going to have their own analytics that they're going to want to do. And that, I think, is a really important part of QIF, is that it makes it super accessible for companies to be able to do that. Yeah.
So on the example with the keto non-dimensional quality,
Yeah.
I was curious, in the CAD world, how are they basically specifying that it's then being pulled out into QIF? Is it purely they're looking at the QIF standard and then doing something within CAD to try to
Yeah.
track that? Or
No, it's a good question. So the way that it was done is that we were placing PMI on the model that was associated to certain surfaces. That PMI, like, since there is no standard for visual inspection like Y14.5 or something, we came up with, we sort of started defining conventions for how to specify that with notes, and then actually parameter data underneath the notes. And that contained a lot of the information that they needed in terms of, like, knowing what type of inspection to do, because there are various different types of inspections they could do with their camera tool. And actually, it kind of raises an interesting question about, like, the area of visual inspection in general, and that is, right now, it's not the normal practice for someone to put an annotation on a drawing even that says, you know, carry out visual inspection here, or, you know, whatever. Usually these types of checks are done with, you know, a PDF document that has you know, all of the quality characteristics that are applicable to maybe a certain part family or something like that. And so there will be someone who's an expert on that particular document, and they own a family of products, and they have to understand how to apply that, you know, all those quality characteristics to the part in question. And so there's kind of it kind of gets into the idea of implicit quality controls on a specific part, rather than explicit controls on a part. And so that's the kind of thing that right now is typically done in an implicit way, which, I mean, it has its pluses and minuses. I think it's safe to say that a lot of companies are struggling right now with the amount of implicit tolerancing that takes place on any of their parts. And a lot of companies are trying to get towards the idea of trying to be a little bit more explicit about how things are done because of the lack of uniformity of how a lot of these types of you know, quality controls are implemented downstream. But yeah, no, that's a good question. Yep.
One more question. So about non-dimensional inspections, what about surface finishes? Like, typically, you mentioned you didn't use detailed dimensions. Is there any use case where you would, you know, some user enter the surface finish specification in the model and Creo or whatever, and then you need to inspect that and kind of compare, you know, inspected versus design? That kind of falls under that category of the non-dimensional?
I think, yeah, in a way, yes. I mean, it's kind of like, yeah, it's kind of in a gray area between dimensional and non-dimensional. But yeah, I think that's exactly right. I mean, so you're not going to measure that on the CMM. So CMM software is going to ignore that. So it's not about reading a surface finish tolerance into a CMM. But a surface finish annotation in Creo is a semantic entity, obviously, that has, you know, all the information related to what the tolerance is and also what surfaces are controlled by that particular entity. That's hugely useful information. And, you know, it's pretty common that, you know, users will ignore the machine readable side of things and make sure that their surface finish annotation, as long as it looks like a surface finish annotation and it has a leader line pointing to the general correct area, that's good enough. But it's important to remember that, yeah, I mean, there are machine readable use cases. I mean, if nothing else, generation of a process plan for that. You know, you could do, for example, in MBD Video, this ballooning process, and to be able to understand that I'm looking at a surface finish tolerance rather than like maybe you use a custom symbol for it or something like that. You know, to know that like, oh, this is a surface finish tolerance. You can make decisions based on that, you know, how this is going to be inspected. And then I think the same thing in terms of analysis of results. You know, maybe you have different types of surface finish, different levels of surface finish that are called out on different parts. You have a huge set of data and you want to do some analysis on that data. Yeah.
From the customers you've worked with, anybody evaluating surface finishes?
Not a lot, to be honest. I don't think I wouldn't say it's one of the bigger use cases. Probably largely because, you know, again, 80% of the tolerances on a part, or the annotations on a part, are dimensional. So yeah, not a lot on surface finish, yeah. Yep. Yeah.
I apologize if you already addressed this, I missed it, but the QIF file format, can that also be used for programming a CNC machine for machining component?
Yeah, it's a good question. So the question would be, like, yeah, can you use the QIF for machining? So, like, I guess there are a couple different things, like ways that you could interface with CAM software or with machining in general. One would be generation of the CAM program itself. And so for that, I'm not aware of any CAM tool that's doing anything with QIF. But to be honest, I'm not aware of many CAM tools that are doing a lot with PMI. Like, so there are, I think, use cases for the use of some callouts on a part in terms of generating a CNC program. But a lot of the dimension, or a lot of the annotations on the part would simply be ignored. You know, maybe you could look at like surface profiles and things like that. So it's interesting, but like I think the use case for that, just in terms of MBD, is not quite as big as it is on the quality side. One area, though, that I know is kind of a big area, and it's one that we do, some work with one of our users on in a pretty big way, is machine tool adjustments based on quality data. So, you know, they're making the same part over and over, and as they watch the trends on the quality controls in terms of, like, they put manufacturing tolerances on them to tell, you know, X and Y direction, you know, deviation on certain things, and they watch the trends on things, and as things start to drift, they'll adjust the machine tool program to correct for that. And so I think definitely applications like that where you're kind of tying together quality and manufacturing, like there definitely are use cases.
There's two things I can think about immediately. One would be the fact that if you can't, that means you have to have another published artifact, step file or something, and you're doubling your publishing and documentation control.
Yeah.
But also things like if you have a 1-inch hole with a -10, -20 thousandths tolerance on it, the CAD or the model is going to say 1 inch. But if they machine it to 1 inch, if a user doesn't interface and adjust the program, you're going to get an out-of-spec part.
Okay, like you might want to go on the plus material side, kind of, you're saying?
Yeah.
Like aim for the, yeah.
geometry is going to be at plus. The geometry of the model is going to be outside the tolerance of the hole that you specify.
Oh, I see what you're saying. Yeah, right. Yeah. And so, I mean, so to that extent, yeah, I think that there are some use cases for how CAM could use PMI. But as far as I'm aware, I don't know that anyone's gotten into QIF consumption. I know that Sandvik Group is taking a serious look at that, and they have, you know, Mastercam and GibbsCam. But at this point, I don't believe that they've like really gotten into it. Yeah. Any other questions? Yeah.
Can you talk about your release cadence?
We typically release 3 times a year. And for some of our users, for special cases, like we'll end up releasing at a faster rate. But our normal release pattern is 3 times a year. Yeah.
And how far behind Creo?
Oh, I mean, we're usually, you know, a couple months. I mean, we can update to the newer version of Creo much faster than our customers can. typically speaking. So yeah. Yeah. Yeah.
How are the QIF files serialized or mediated between as designed and as built?
Yeah. So, so yeah, the question is, I mean, in general, I think, how do you manage QIF files? So typically what will happen is that you'll have a QIF MBD model that will be stored in Windchill and associated with your part. And for that, you'll have a one-to-one relationship between your QIF MBD and your Creo model. Then you might start to layer on other information. And like, let's look at the simpler case where we're starting to collect measurement result information. Typically, that will be stored as another instance file. So you'll have a QIF file in Windchill, and then you gather up a batch of results. Let's say you have a QIF results. You have a .QIF file that has these results. That probably is not going to be stored in Windchill. But those results files will point back to that master QIF MBD that they came from. And so that QIF MBD, that original one, it's important that that is stored in Windchill because that's sort of your hub for your entire data universe. And then those results, when you look at the results, you could find the pointer back to that location in Windchill. And so those QIF results files, you might have, over time, you might start to build up a lot of those. And they could be stored wherever, your local QMS system, whatever. So that's, like, typically it's something like that. I mean, it is sort of a federated data model where you have, multiple different instance files that all serve their role and they all can kind of reference each other. Yeah, does that kind of answer your question? Okay. Any other questions? All right. Well, thank you, everybody. And yeah, please come by and talk to us if you have any questions.